All right. Tonight's talk is how not to debate a geologist. He was a very nice man. But before we do that, I'd like to show about what we did on the 4th of July. We handed out a lot of these freedom tracts. Can you guys hear me okay? Yep. Just raise your hand if you can't. We handed out probably 500 or 600 of these on the 4th of July.
You said Joe?
Yeah.
Yeah, I saw you.
Oh, you did? You saw us there?
The other side of the street.
Oh, yeah. If we would have had, more people, we could have got both sides. But we handed all of them out on that side, even before we got all the way down. And I want to get people to know what our freedoms are. Because if we don't know what our freedoms are, then they'll be taken away. Tyrants will have a heyday with us. And so, I have yet to meet anybody who's taken an oath to the Constitution who can tell me what's in the First Amendment. Does anybody want to take a stab at it? If we don't know what our freedoms are, we could lose them. And also people violating our freedoms won't realize it. So it's basically the freedom of religion, speech, press, petition the government, and peaceably assemble. Those are the ones. And then we threw this in for good measure. Why did the Pilgrims come to America? Well, we, by the grace of God, having undertaken for the glory of God, right, an advancement of the Christian faith. That's why they came. And then were we evolved or were we created? Well, the Declaration of Independence tells us, we hold these truths to be self-evident, that all men are created equal and they're endowed by their Creator. So we were created. And I want to get this into the mainstream of our community. And then on the backside, we also talk about, are you free from the bondage of sin? And if you died today, where would you go? These are some important topics. And next year, I hope there's thousands of these handed out, and I can put anybody's church on at the bottom. And I'd also like to see this banner going through the 4th of July parade. May God bless America. Everybody wants that, right? As America honors God. Are we honoring him in the science room? No, they kicked him out of the science room. And so we're trying to change that. And so hopefully we can start a snowball of what our freedoms are and what God has done and get our country back on track. Okay, going back to this proper perspective of geology. A few months ago, Donnie from Standing for Truth contacted me and said, hey, do you want to debate a geology professor? And it's like, oh boy. I sent it up the flagpole, see if some of the hydroplate people want to debate him, and they didn't want to do it. So now it's like, okay, do I debate this guy? He's way out of my league, and it's like, well, I've been praying for open doors. This is an open door, but he's a pretty sharp guy. But then it occurred to me, we've been trying to get plate tectonics critiqued publicly for years, or catastrophic plate tectonics. We've been trying to get them to sit down, and they haven't done it. Where this is an opportunity to critique plate tectonics publicly. And so I said, I'll do it. And I did it last Friday. Did anybody see it? Okay, it's a 4-hour debate, and it's probably just as good, because somebody emailed me before that. They said I was to the undefeated debate champion, because I debated a science teacher and a paleontologist and an evolutionist and another guy, and they called me the undefeated debate champion. But I don't think I'm going to get that anymore, because I don't think I did very well. Okay, I think there was a lot of things I could have done better, so I'll go through with what I think I could have done better. So this is how not to debate a geologist. Okay, you can learn from what I'd like to do differently. There's some things that I should have pushed back on, but I didn't really have time, or it kind of surprised me. So here's some of the highlights. One of the things is he's saying that, hey, this whole book is full of errors and outdated sources and misinterpreted sources. And so one of them that he was talking about in his opening statement was, that these water pockets don't exist under the crust. He's saying there's no water there. Okay, that's what he's saying.
These water pockets, they don't exist because they would block shear waves from earthquakes, and you'd have a shear wave shadow on the continent, and that's never been observed.
Yeah, it's never been observed. He says that there's no water there at the beginning of the debate, but then listen to how he says there's water everywhere at the end of the debate. Well, how about Brian, when he predicted they'd find water under the mountains? How about that one?
Why is that a problem?
Well, he predicted it, and then they found it. You said he didn't make predictions.
I don't know why. I mean, there's water almost everywhere.
Well, nobody else predicted it.
Well, I don't know. It's such a trivial thing that why would there not be water under mountains? I don't understand where that's a problem.
Well, he made a prediction. The point is he made a prediction and it was confirmed. That's a far cry from him being wrong on everything and not making.
Well, that's a trivial thing because
Well, you're going after his character. That's not trivial. You're saying he's a liar, and that's not trivial.
Well, there are many statements in that book that are false.
Well, he also made accurate predictions. And I'd like a list of the predictions, the current predictions of the plate tectonics theory. I'd like to see that.
Well, but there's already been so many predictions that were proven true. How many?
Well, right, but there should be current predictions so we can know if it's on the right track.
Well, I'm not a plate tectonics expert, so I can't answer that.
Yeah, so he said there wasn't water at the beginning, and then at the end he says, well, of course there's water. And then this one was rather interesting also. Okay, how did the 90 East Ridge form?
So there was a hot spot, and as India is moving north, the hot spot stayed stationary. So as India moved north, it left behind a series of volcanoes.
Okay, interesting. And I knew that was wrong when he said it, but I didn't have time to go back and say it. So we'll just do it right here. If you want to listen to it at rsr.org, Hawaii Hotspot Hypotheses Widely Discredited. And I'm not sure if it's this show, but there's another one where there's a national park ranger that talks about how hotspots don't work. And just to real quickly, I typed it in, was 90 East Ridge made from hotspots? Now this is AI. I take everything from AI with a grain of salt. I think that's propaganda on steroids. But testimony contrary to interest is important. So what did AI say? Was 90 East Ridge made from hotspots? So it says, the evidence suggests that the 90 East Ridge was not formed by hotspots. Okay, so just consider that. He's saying that Waltz Brown is wrong about everything. Well, there's a couple of things that he changed his thing on, and it went against AI. So, and encourage you, don't believe stuff just because I say so, or because he says so, or because Walt says so, but get all the information and then come to your own conclusions. Yeah, I'm talking about, see, if he's interested in errors in this book, I was trying to find out if he was interested in the errors in our science books, and we discussed that a little bit. They don't care. They'll teach what the state standards are, even though the standards are wrong. They still want the Haeckel's embryos. That's the state standard. They have to show that the embryos look like each other, and that was proven wrong 100 years ago. So if you're against Walt's book because it's got errors, man, you should be against those high school textbooks that got errors, and they're probably in the college textbooks too. Can we join forces, you and me, and get the errors out of the textbooks?
Well, you're talking about errors in which I have no expertise. I don't know anything about genetics. I don't know anything about
Do you pay taxes?
Genetics.
Do you pay taxes? Do you want your taxes being used to tell kids lies?
Of course not.
Okay, well, this is what's happening.
But it's your impression of what's a lie. That may not be the same as mine.
And what I should have said right there was that I'm using Nature and NASA and Smithsonian, the PubMed, these government documents to show that the textbooks are wrong. I should have said that then. So again, this is how not to debate them. But just a real quick example, these are images of Haeckel's fake drawings. And these were proven, it doesn't matter if you're a chicken, a bunny, or a human, they all pretty much look the same. But those were fakes. This is what they actually look like. They don't look anything like he drew. They don't look anything like each other. And yet it's still in our textbooks, even after they say it's embarrassing but true. Some of the most influential drawings in the history of biology are wrong, exaggerated to fit a thesis. So this is what's out there, and this is in our St. Cloud textbooks, 2024 textbooks. And so I'm just, if he really wants accuracy, how many people are looking at this book? Not many. But how many people are looking at the textbooks in the school? All of them almost. Okay, unless you're homeschoolers. And I talk to people, students from Sauk Rapids who see this, people from St. Cloud who see this. And I'm hoping that Christians and taxpayers get upset enough that they don't want this taught in school. And so there's just one more professor out there, and anybody who sees the debate will, anybody who sees this will see that. And then he objected to that bowling ball analogy, how the weight of the Himalayas causes the world to roll. And he says the Himalayas will not add to the rotation of the Earth, because if you make the bowling ball as small, just perfectly smooth, the Himalayas are only 1,000th of an inch. And that could be, but at geology.com it talks about earthquakes. A shift in the distribution of the Earth's mass, magnitude 9.0 earthquake in Japan, may have shortened the length of each Earth day and shifted its axis. Okay, just an earthquake, just a little shift can make it shift. It could increase the rotation. The Japan quake should have shifted the position of the Earth's figure axis, the axis about which the Earth's mass is balanced, about 17 centimeters. And it also talks about adjusting the rotation of the Earth. And so just a little shift in the Earth's crust can do that. Just think if the Himalayas went up, what that could do. And again, just take all the information and think for yourself. My opening statement, since we're debating how the Earth got to be this way, my strategy was to show what's on the Earth and then show out how the plate tectonics, or how the hydroplate answers those questions. And so I went through and I just showed them the mid-oceanic ridge and the tension, which is made of tension cracks, which is different than compression cracks, and how the mountain ranges are parallel to the mid-Atlantic ridge. And he objected at this. He says they're not parallel. They're not perfectly parallel, but he said that those are not parallel to the mid-Atlantic ridge. And I look at it, it's like, well, they both start in the north and end in the south. That's pretty parallel in my book. But in his book, he said this is one of those false informations that Walt projects. We talked about the plateaus and the 90 East Ridge, and Mount Everest, the highest place on Earth, Mariana Trench, the lowest place on Earth, Ring of Fire, trenches. You've seen all this stuff. 40,000 volcanoes. Zealandia got sucked in. Palm trees in the South Pole, all these things in the North Pole, and there's saltwater creatures found in every layer. Every one of those geologic layers has saltwater creatures in it. You got a bunch of whales fossilized in the driest desert in the world. And then in Peru, you got hundreds of fossils, 3,800 feet above sea level. That's a weird place for a whale, along with ground sloths, and big, massive dinosaurs have been found, frozen mammoths standing up, inland seas, salt domes, Grand Canyon, the Great Denudation. This is Red Butte, a remnant of the Great Denudation. And this is an interesting one. You got folded rock layers at the Grand Canyon. How does that happen? And then these layers aren't just at the Grand Canyon, they're worldwide. And then you got slanted layers underneath flat layers. I wish I would have asked him that question. That one's going to the top of the list next time. A 5 to 10 ton rock lifted up into sedimentary rock, and the submarine canyons. And this one is rather new. I don't know if you guys have seen this one. This is a water gap. And the really fun thing about researching for this debate was I learned about Ron Neller, Dr. Ron Neller. He was a fluvial geoformologist. Basically, he's a flood chaser. He loves to see how the surface of the Earth changes. And he's from all these things around the world. It's like, man, there was a worldwide flood. After 30 years of looking at it, and it made him realize, what? The evidence brought him to a flood. And this is one of the evidences. This is a water gap. That river that's 3,400 feet above sea level, it doesn't flow around those ridges. Those ridges are 850 feet. So those ridges are 500 feet above the river, and yet the river flows through it not once, not twice, not 3 times. You go upstream, there's a 4th and 5th time. That river flows through those ridges 5 times. That's interesting in my book. And then there's billions of round quartzite rocks on plateaus from hundreds of miles away. And so all this stuff is helping Ron Neller realize there was a worldwide flood. And the geology professor, he knows his sedimentology very well, and the way he interprets the sediments is saying there's no way there was a worldwide flood. So we're kind of talking past each other during the debate. We talked about the Ice Age with no glaciers in parts of Siberia and Alaska. The Earth's oldest rock found on the moon that was formed 12 miles beneath the Earth's surface. And then this asteroid Bennu, it has serpentine in it, where it's formed when mantle touches the water. Okay, and so we have all those things. That was the first part of my opening statement, and then the next part of the opening statement, I explained it with the hydroplate theory, and you guys have all seen the hydroplate theory probably multiple times. But if you haven't, I've got a playlist on my YouTube channel called Solidify Your Faith, where I help, where it's you can get up to speed there. So I won't go through that part of the debate here. You've probably seen it. And then the rebuttal. If I would do this again, I would rebut what he said in his opening statement. I would focus on dismantling that. But my goal for the rebuttal was to have people realize there's a lot of PhDs that don't go along with plate tectonics. Like a lot of them. This isn't a slam dunk. This isn't a settled fact like they try to imply in the textbooks or in the journals. And so my rebuttal was going to talk about, is this high confidence science or low confidence science? How do you evaluate a theory? What are the other PhD is saying. And Dr. Rob Stadler, he's got this book, The Scientific Approach to Evolution, where he talks about, if you want it to be high confidence, and for tonight's discussion, it needs to be repeatable, observable, no bias and no assumptions. That's when it's high confidence, But if it's low confidence, is that what we debated? Is it repeatable? Can we see another Earth being formed? No. Is it directly observable? Can we watch, the Mariana Trench form, and can we watch these salt domes form, or layers being laid down? We don't. Is there any bias? Well, this depends on how you do testing. Do you do blind tests with the rocks, or do you send in a whole bunch of information with the rocks? And then careful to avoid assumptions. And that would be uniformitarianism. Okay, his assumption is uniformitarianism. So clearly this is low confidence science. This is not high confidence science. There's no double blind tests or anything like that. This is low confidence science, and I can make an argument that it's not even science at all. Because according to the National Academy of Sciences, they define science as the use of evidence to construct testable explanations and predictions of a natural phenomena. Okay, what are the tests? Can we attest it? Can we observe it? And the tests aren't there, and the predictions certainly aren't there, at least as far as he knows. I asked him that. And then how do you evaluate a theory? Okay, to explain an unobserved, unrepeatable event scientifically, we must first assume the conditions existing before that event. From these assumed starting conditions, we then try to determine what should happen according to the laws of physics. Okay, and then he gives us 3 criteria. First, if from these starting conditions we can explain all relevant observations better than any other proposed explanation, confidence in our explanation increases. Yeah, because we can explain the comets and the asteroids. They can't. And then second, if a few assumptions allow us to explain many things, then confidence in the explanation will be great. Okay, conversely, if we need to make many assumptions to explain a few observations, or if new observations cause us to modify our proposed theory, which has happened with uniformitarianism, then we should have little confidence. Okay, and then finally, this is the big hitter right here. Okay, a legitimate theory allows us to predict unusual things we should soon see if we look in the right places. Verified predictions greatly increase our confidence in an explanation. Published predictions are the most important test of any scientific theory. And so you can check this out on page 447 and 449, or you can go online and go into creationscience.com, and you get to look at a flip book of this for free. So I encourage you to go in there and check out the hydroplate predictions. There's 59 of them. There's 10 of them that are in green that have been confirmed. Or you can go into hydroplate.org and go into HPT predictions, and Fred McNabb's documents where he says there's 20 of them that have been confirmed. And so you can go take that and then compare it to the plate tectonic predictions. And then you can compare them head to head. These are the theories on the top, the features on the side, and hydroplate and plate tectonics are trying to explain ocean trenches, earthquakes, and the Ring of Fire. And the way you read the graph is red, yellow, green. Okay, red means there's serious problems, yellow means there's moderate problems, and green means there's no problems. So underneath the hydroplate theory, there's no problems for the most part, but underneath plate tectonics, serious problems all the way down. And you don't just believe my interpretation of it, or Walt's. Go into page 175 where he talks about every one of these, and he compares them, and he gives secular journal citations. And then there's this NCGT journal. It's a voice for new research in global tectonics. Okay. Bob Enyart, he went through that and he got a list of all these all these geologists who do not go along with it. And you can go into rsr.org, and it's titled Plate Tectonics, Subduction Doesn't Happen. And you can listen to Walt Brown be interviewed and discuss this. And you can scroll down there a little bit and you can find a whole bunch of, a list of geologists rejecting plate tectonics. And one of them is blank, because he doesn't want to put his name out there, because he knows if he does, his job is in jeopardy. In America anyway, you look at a lot of these are from overseas. They have more freedom to think over there than we do over here. All right, and then this one was N. Christian Smoot. He's the guy that mapped the ocean floors, and he knew what was down there, but it was confidential, and he couldn't release it. And Walt Brown says, N. Christian Smoot, an evolutionist, spent 32 years precisely mapping the ocean floor. His book, Tectonic Globalone, describes discoveries on the ocean floor that falsify plate tectonics. And it talks about ocean floors during this time. 70% of Earth is under the ocean. Okay, so when they're making plate tectonics, They didn't know what 70% of the Earth was. Okay, the ocean floors were largely unexplored between 1957 and 1970 when the plate tectonic theory was developed. So there's a lot of unknowns, and Christian Smoot has the data that shows that what they're saying is wrong, but he couldn't release it. And this Howard Meyerhoff, he was a big hitter at the American Association for the Advancement of Science. He was a big hitter at the journal Science, and he wrote this in 1972. Right when plate tectonics was coming on the scene. He writes that geologic and geophysical data from the ocean basins and the continents are now sufficiently abundant to demonstrate that all proposed models for the new global tectonics are seriously in error. So they didn't have good information way back then, 1972. And then if you go into another one, rsr.org, deep magma can't rise but sinks, the crossover depth, you can scroll down there and you're going to see geologists who reject magma plumes. And those are kind of the driving engines for convection that gets the plates to move. And one of these is Warren Hamilton. And he won the Penrose Medal back in 1989. The Penrose, that's like winning the Nobel Prize. It's the best of the best of the best that year. And that's what Dr. Hamilton was. He was the best of the best of the best in 1989. And he believed in plate tectonics, but came to realize that a generally accepted component of the theory, mantle plumes, is wrong. So then in 2002, he writes this essay that says different rules of evidence apply to conventional wisdom, where evaluation is not necessary. But if you want to challenge that conventional wisdom, now the proof must be overwhelming before they'll even have a discussion. And that's what I've seen in my lifetime. Yeah, I've seen that. It's like, well, we've got such overwhelming evidence. What do you got? And they won't even sit down and talk. And he writes that appalling papers in support of plumes are now being published in major journals. He writes that suppression of dissent is common. I know of many recent examples wherein prominent members of the dominant pro-plume community have stifled anti-plume reports and research. So you can't get the grants to research something that's going to falsify that. And so it becomes a self-fulfilling prophecy. If the people who control the research money only fund people that are going to agree with what they believe. And so I think that's still happening today. Although such perpetrators might tell themselves that they are maintaining professional standards, bad science is to them anything contrary to their own conjectures. And widely accepted assumptions regarding the composition, evolution, and behavior of the mantle appear to be in error, yet evaluation of alternatives is actively discouraged. Okay, actively discouraged. And he says that basic assumptions often are so entrenched that the practitioners are unaware that there might be little or no evidence behind them. For example, modelers of convection are unaware of elementary plate tectonics and do not realize they provide no explanation for plate motions. So convection doesn't move the plates. Remember that. That's from a Penrose Award winner. And then he says science advances primarily when many of us are proved wrong. Breakthroughs, by definition, surprise most people. And again, we're living at such an exciting time right now. We're seeing all these breakthroughs. I believe we're going to see breakthroughs in the Big Bang, evolution, the geologic column. All those things are falling apart. And we're watching it. We can help that happen. And then this Penrose Award winner, Hamilton, he has this paper. And he says, purported critical evidence of plume speculation is false. Plume fantasies are made ever more complex and ad hoc to evade contradictory data and have no predictive value because plumes do not exist. And again, this is from somebody who won the equivalent of the Nobel Prize. And then in 1999, Science Direct, they say, superficially, the mantle plume explanation seems attractive and has had a tremendous appeal. However, its numerous built-in fallacies, contradictions, and failings are unfortunately little discussed in much of the current literature, and it has acquired the status of an unchallengeable dogma. And that's what we have in science in America. We've got unchallengeable dogmas like the Big Bang, evolution, the geologic column. It's the dogma. If you start questioning that, that could be hard for your career. Okay, and then subduction, initiation in nature and models, a review. This is 2018. says, how do you get the plates to move and subduct underneath? How does that begin? Well, they don't know. Subduction is a major process of plate tectonics. However, its initiation is not understood, and it's incompatible with the Earth's surface, geometry, and geomorphology. This is from 2019. And it says the geometric shapes do not correspond with the expectations of the plate tectonics theory. There is an irresolvable contradiction in plate tectonics subduction theory. And then, let's see, in 2020, it says 50 years after the foundational works establishing the geometrics, kinematics, and mechanics of plate tectonics, we still lack a consensus understanding of how the plate tectonic systems initiate. They still don't know after 50 years. It says also, despite considerable theoretical effort, we are unable to directly connect the parameters of these models to the laboratory-derived microphysical properties of rocks, and instead must tune the model parameters to match observations of Earth's plates. So they can't make it fit, so they have to adjust the model. And remember, if you have to adjust the theory or the model, your confidence should go down. And again, this is from Nature. Okay, another one from Nature. It says, the formation and preservation of cratons, the oldest parts of the continents comprising over 60% of the continental mass, remains an enduring problem. And this is from 2021. That's a problem, especially when they sink down there 90 to 150 miles. That right there should stop the plates from moving. They're not smooth. Okay. We talk about increasing confidence. Well, does the hydroplate theory do that? Do the starting conditions explain many observations? Yeah, it does. From the Mariana Trench to asteroids and comets, and it has one assumption that explains many features. Yeah, check mark there. And it has accurate predictions. Check mark there. So the hydroplate theory, based on these three features, I believe, is better than plate tectonics. And plate tectonics, catastrophic plate tectonics, is just plate tectonics sped up. And they don't have predictions either. And so I think we need to discuss this. And Walt says, avoid the tendency to look for someone else to tell you what to think. Instead, question everything yourself, starting with this book. He says, yeah, question it. Question it, and then question other books too, and then get all the information, and then come to your own conclusion. And I'm so excited. This book is now available in print. It's only been out a week now, all right? It's finally there, and you can get it on Amazon or at Real Science Radio and rsr.org's store. But on Amazon, it's $89. But guess what the 7th edition was? $125. And these books, like the 7th and the 8th edition, was just a $30 book. Okay, and it's got a copyright of 2009, I believe, for the 8th edition. These ideas, these withstand the test of time. This isn't like your college textbooks that they give you $10 for, or won't give you anything the next semester. So again, it's available, and again, you can see it for free at creationscience.com. And then you can also get, if you like some technical reading, click Tectonic Globaloni, see what the guy who mapped the ocean floor has to say. And he doesn't go to the professors anymore. He says their minds are made up. He's going to the college students. Their minds are still open. And he's showing them the data. But if you don't want to read that, let's see. You can go into hydroplate.org. Ellen McHenry, she did a summary of this. You can get the gist of it. Or you can listen to her being interviewed at rsr.org. And while you're there, you might enjoy Walt Brown and Brian Nickel. Their interviews are excellent for the hydroplate. And then this book, let's see. You can, and again, this book here, it's for the scholar and it's for the average person too. The chapters are easily understood. You can understand the way he writes. But then at the end of the chapter with the citations, that's where the formulas are. That's where the scholars can go. And so again, it's written at 2 different levels, and I think it'd be a great Christmas gift or a birthday gift. And then this book too, 20 Reasons to Question Plate Tectonics. You can listen to, they talk about this on Real Science Radio. Otherwise, at the Hydroplate Conference, Fred Williams does a great presentation on this book. So in an hour, you can see what the major problems are with plate tectonics. All right, and then you can go also into page 186 at creationscience.com, and Walt's got a list of why subduction cannot and has not happened. They'd either crush the plates or pull them apart. The sediments, volcanoes, and plateaus haven't been scraped off at the subducting plates. The sedimentary layers in the trench are undisturbed, and they shouldn't be. No known forces are available to break the crust into plates and separate those plates from their bases, contrary to what the geologist is going to say in a little bit. Subduction cannot occur along along an arc. Below trenches are mass deficiencies. There should be a whole bunch of mass. There should be a lot of gravity pulling you down. You should weigh more over those trenches, but you don't. You weigh less. And then also thick buoyant continents would prevent subduction, and subduction plates would not reverse direction, and they do. Trenches and ridges do not have corresponding lengths. There's 3 times more places where the trenches where the ridges are forming new continent than the trenches or the subducting continents or plates. And then there's 3, this is kind of technical, I'll let you go into that, but there's 3 locations on Earth. It's called a triple junction, where they intersect, where the ridge and this is supposed to be going up and down at the same time. So that's a little hard to explain. All right, so that was the rebuttal. And then we had cross-examination. And my strategy here was to pound plate tectonics into the ground so that catastrophic plate tectonics follows it into the ground. So I was asking questions mainly to reveal weaknesses in plate tectonics, not so much to show a worldwide flood. And so I asked him, how thick are the plates? And he told me, and I asked him, how many plates are there? And he didn't know. He didn't know how many plates there were. And so I showed him from Wikipedia, there's 7 major plates, 15 minor plates, and 1,200 micro plates. And I asked him, what force and mechanism breaks the crust into 1,200 plates?
Mantle convection.
Mantle convection. Mantle convection. Remember that Penrose award writer? He wrote that mantle convection doesn't move the plates. Well, if it can't move the plates, how can it break it into 1,200 places? So if I did this debate again, if he said mantle convection, I would ask him, well, how would that happen? How would you break the Earth's crust, 60 miles thick or whatever it is, into 1,200 pieces? How would that work? Then I asked him, how did subduction begin? And he said, I can give you some citations. Okay, and then I could have asked, what are they? But this was the part of the debate where I wanted to, I had a whole list of questions that I wanted to ask. And I didn't want to get bogged down on any certain one. And so I probably should have followed up on certain ones, but there was sometimes when he would start talking, and it would just, professors can talk, and it's like, okay, let's move on, let's get on to the next question. And some of the stuff he was saying, like, well, I haven't been to this one, but I've seen it. But anyhow, all right. And then, how does a plate get pushed or pulled without crushing or cracking the plate? And he said the density of the plate and the convection in the mantle, that's pulling it. Again, that's Dr. Hamilton wrote that convection doesn't move plates. So there's a lot of assumptions that are assumed to be true. And then I said, why are divergent areas? That's where the crust is coming out of the Earth, supposedly. The Earth is growing there. 3 times more than the convergent areas. That's where the crust is going in. And he says, because the rate of subduction is faster at the convergent areas. So it's getting, and I said, well, that's like a 6-foot conveyor belt coming out of the wall on one side, getting sucked, going into a 2-foot conveyor belt on the other side. And he said, no, it's not. And it's like, well, how else is that going to be? But you can go into that. Then I asked, how do plates reverse direction? And he said, well, what plates? And I didn't know. He said, what's the citation? And it was number 17, and I didn't want to spend time digging it up. And if I do it again, I'd ask, if this is true, would that change your position? If plates actually do reverse, would that change your position? And then, so now that I have time, I went to citation 17, and this is one, Walt Brown, uses outdated sources, and he misquotes them. So let's see if that accusation is correct for this one right here. This is from Science News. This is from 2013. Does that sound outdated? 2013, 13 years ago? I don't think that's outdated. And it says, occasionally tremor reverses direction and speeds up dramatically for a little while. Why that happens remains a mystery. Okay? And so it does happen, and I think Walt accurately quoted it. And so, and again, check out the sources for yourself. How did the Mariana Trench form? And he said subduction. And I should have said, well, how'd that begin? And I asked and I could have asked this question for the other one too, why are most of the trenches in the Western Pacific? And he said the Atlantic Ocean formed as the continents separated, so there's no subduction in the Atlantic. If you expand the crust in one area, you have to contract it in another. But that's, okay, so the trenches, I should have said right then, well, why didn't they subduct at the plate boundaries? Why didn't they go where they're supposed to be subducting instead of right in the middle of the plate? You got these huge drop-offs. You know, it's that Mariana Trench is deeper than Mount Everest is high by a mile. You know, why did it sink in at the middle of the plate where hydroplate, you know, can clearly explain that? And how do trenches form with arc and cusp shapes? There's actually, and he said, well, there's actually a paper that shows if you start with the physical properties of the plates and let the subduction run, you'll end up with arcs. And I'd emailed him afterwards. I asked him, what are the errors in the hydroplate? And he sent me a bunch of errors, and this is a couple of the citations. So this is his paper to explain how they form in an arc. And this is from 2011. Okay, so clearly 2013 wasn't outdated if he's using a 2011 source. And so let's take a look at this one. And it said, here we present theoretical arguments. So this is in theory how it could work. This doesn't show in practice how it should work. And it's a formulation and it's a theoretical relationship. And then the other one, this one says that using a numerical model of mantle convection. So these are models. Okay, so this is his proof that they can go in that arc and cusp, but these are models that they can adjust to make anything work, basically. There's a saying out there that says all models are wrong, but some are helpful. Okay, and so again, theoretical models don't inspire a lot of confidence in me, but maybe it will in other people, and you guys can check this out. And also remember, we quoted this earlier, despite considerable theoretical effort, we're still unable to directly connect the parameters of these models of the laboratory, and we must tune the model parameters to match observations of Earth's plates. So again, they're messing with the model to make it fit what they find in the field. And then I asked them, why are the rocks of St. Peter and Paul dated at 2 billion years? You know, this is where the mid-Atlantic ridge pokes out of the water there. And so they date those rocks, and that's where the Earth is supposed to be forming. That should be the youngest rocks. Okay, and so that's, and it should be 10 million years. And so his response to this was, he looked at the citation, he says, well, who knows what errors are made from 1972? And I should have asked him, well, if this is true, if they get an updated date on these rocks, would that make you change your perspective? And so there's a lot of things I left on the table. And I asked him, do you date rocks? Have you dated rocks? And he said, personally? And I said, yeah. And he said, no. And I think he reinterpreted my question. I should have asked what I had. What process did you follow to date rocks? Because my guess is he sent in rocks to get them dated. He didn't do it personally, but he sent in rocks. And so if that's the case, I would have asked him, well, what information did you have to send in with the rock? And how many samples did you send in to get a layer dated? Because this is Ron Neller, and you can see this at Ron Neller Creation Ministries 5-11-25. That's the title of it. You can watch this on YouTube. And at the 37-minute mark, 37:30, he says he gave up radiometric dating. You know, if he wanted to date a rock layer, he'd send in 10 samples from the same layer and get 10 different dates. And then he'd just pick the date that best fit his story. And so, eventually, I'd encourage you, listen to as many of these. He's just got the neatest testimony, and he paid a price. You know, when he said that there could be a God, boy, his career just fell apart. Okay, then I asked, how does supercritical water get under the Atlantic Ocean? He goes, where? And I said, well, and I explained where. It's just south of the equator in the mid-Atlantic ridge. And he says, well, the water hits the basalt. And I said, yeah, but it should turn to steam. When water heats up, it turns to steam. It needs to be under 3,200 psi to turn to supercritical. And he says, well, what's the source of the article? And so I told him, this is New Scientist, August 4th, 2008, Catherine Barrick. And he said, well, I'll have to look at that. Okay, and then I asked him, where did all the limestone come from? And if anybody ever asked this question to anybody before, set the stage. And I didn't set the stage for this. I said, Dr. Walt Brown, he met with Bob Dietz. And Bob Dietz won a Penrose Award also, so he's like a Nobel laureate. And so he met with him every Wednesday for a school year, and they'd talk about different things, and they'd go and listen to a geologist that night, and they'd have meals together. And he asked him, he said, where'd all the limestone come from? Because when a molecule of limestone forms, it releases a molecule of carbon dioxide. And there's 60,000 times more molecules of limestone than there are molecules of carbon dioxide in the atmosphere. And so Walt asked him, where'd all the limestone come from? And Bob says, beats the blank out of me. He doesn't know. Okay, and so then anyhow, but you can listen to that on the thing. And we talked about the Bahama Bank, which is a big limestone layer, which is 250 miles by 800 miles and 6 miles deep. So Walt Brown asks, if limestone formed organically in shallow seas, why would the seafloor slowly subside almost 6 miles to allow for these accumulations? So I asked him, how did that form? And he said, isostatic adjustments. As the limestone grew, it sunk in. So that's what he's saying. So I said, it just happened to grow at the perfect rate for 6 miles? And he said, if it didn't grow at the perfect rate, we wouldn't have the Bahamas, which is a logical fallacy called begging the question. That's like saying, well, hey, if evolution didn't happen, we wouldn't be here. We could have been created, okay? And those limestone things could have been laid down a different way. Okay, and then I asked him, where's the world's largest underground salt mine? Does anybody know? Anybody know? You'd never guess. It's underneath Lake Huron, 1,800 feet under Lake Huron. Because I'd always wondered, I always wondered about the Great Lakes. I thought, could they be inland seas? But they don't have salt underneath them. But Lake Huron does. And then he said that there was he brought up calcite. There's calcite there. And, and that's a big component of limestone. And calcite they find everywhere. And I'm thinking this is what formed in the subterranean water chambers is what I'm thinking. But look at these salt features here. Look at the Great Lakes. It's only under 3 of them, but what are the other 2? And so I'm still puzzled a little bit. And then he talked about coral being around there, and so that'd be an interesting thing to look into. And my guess is they're going to find salt underneath Lake Superior and Lake Michigan. I don't know that, but just something to consider. But yeah, and I asked, what formed these major salt formations? I'm not sure if I got to this question or not. But basically, for the one in the Gulf of Mexico, you got to have the ocean water evaporating. It flows in and evaporates and keeps doing that over millions of years. That's how you get it in the Gulf of Mexico. And that Gulf of Mexico layer, it's 100,000 square miles and 1,000 feet thick. So I got a question. How many feet of ocean, to get 1,000 feet of salt, how many feet of ocean would need to evaporate? Anybody have an idea? It's 60 to 1. You'd need 60,000 feet of ocean water to evaporate to get 1,000 feet of salt. That's over 10 miles of water, 10 miles of the ocean to evaporate. In all those different positions all around the world, it's like, well, yeah, I don't know. That's hard for me to grasp. But if that salt was formed in those subterranean water chambers, then that's not a problem for me. And then I asked, why did Russia find hot, salty water flowing through crushed granite 7.6 miles under the Kola Peninsula? Because Walt says that you can't, when granite's under 5 miles when it's 5 miles deep, it's just like putty. It just seals all the crack. There's so much pressure there. And he says, well, that's no problem. There's a lot of wells that go down 6 miles, is what he said. And so I should have asked, but I didn't. I should have asked, where are these wells? And so since then, I just, again, AI, and again, take this with a grain of salt. I said, how many water wells are 6 miles deep? And AI, again, I don't put a lot of faith in them, but AI says wells reaching 6 miles are extremely rare and not practical. So he told us that these wells are everywhere, okay? And that's not, according to AI, that's not the case, okay? And then we talked about his river channels that have to be buried in the sea level, marine animals, then other river channels and marine levels. It's basically he said that the sea level has to go up and down, go up to form these widespread marine deposits, and then sea level goes down and you get the river channels, and then the sea level goes up, and you have to have this happen dozens of times. Dozens of times. And my question was, hey, when the ocean is coming in at high tide and low tide, wouldn't the waves pound on it and destroy those river channels? When you go, and those are some pretty big waves crashing in, high tide and low tide. And as it goes up, it's going to beat on it. As it goes down, it's going to beat on it. And then ask him, well, how does sea level go up or down? And he says, plate tectonics or ice ages. It just happens to have all these things. And my position is, Walt Brown talks about how the plates, as they're slamming down and going up and slamming down, these plates could go up and come out of the surface and then go, and then the water channels off and makes a channel. Then it goes down and then it comes up again, and then water channels off in a different channel, and then it goes down, and do that dozens of times. to me, that's a lot less assumptions than having to have the mantle go up or the ice ages. And he didn't know how the ice ages really started. And then I asked him, how did the Colorado Plateau lift up? And he said he didn't know. This was after, I should have asked him that question first. I read everything before that showed, the way in which the uplift of the Colorado Plateau occurred is puzzling. Rocky Mountains were dramatically crushed and deformed during their uplift. On the Colorado Plateau, the rocks weren't altered significantly. So you got the Rockies crushed together, and right next to it, you got a plateau lifted up very gently. They have a hard time explaining that, but with the hydroplate, it's no big deal. The mountains sank in, were formed during the compression of Mount. And then I asked them, how did Powder River coal seams form? Okay, and this is, you can see this on Standing for Truth, Tim Clary's talk. It's a 200 feet thick layer of coal that's 60 miles by 60 miles. And Tim Clary says when he went out there with a secular professor, his professor said they got nothing to explain this much coal over this much area. But the geology professor says plants accumulate in whatever wet environment and get compressed. And I should have asked him, I should have followed up on that. And he says, where is that happening today? Where is a 60 mile by 60 mile area of ever wet stuff, plants forming to be compressed? But I didn't. So again, I learned from my mistakes. Where's that happening today? And then, then this was the last question. And I wanted my last question to be, do you think there should be competing hypotheses for how the Earth got here? Plate tectonics and hydroplate. That's what my final question was going to be. But I missed it, I blew it. I said, how did the Ice Age begin? And so we talked about that. Because they got all these theories, none of them really work, especially how do you get a glacier, and during the Ice Age, there's no glacier on Alaska and parts of Siberia. Okay, so he said it was the Machiavellian whatever, which works at the few of them, but not at the later of them. And then I asked, how come there's no glacier there? And he says, maybe it's the trade winds. During an ice age, it's going to be really warm there. So anyhow, I think the creation model of the Ice Age, I think that makes a lot of sense. And then my closing statement, and I thought, I can't do better than Walt Brown. And so basically, I used Walt Brown to do my closing statement. These are Walt's words for the most part. He wrote, Dr. Thomas Chamberlain warned researchers not to let one hypothesis dominate their thinking. Instead, they should always have or seek multiple working hypotheses so we can think independently and not simply memorize and conform. Okay, he says, fruitful theories answer not only the obvious initial questions, but also solve perplexing and seemingly unrelated problems, like standing frozen mammoths. And robust theories also provide details that result in surprising and testable predictions. If predictions are missing, the theory is probably weak. If theories could not be published unless they included specific predictions, we would be mercifully spared many distractions, false ideas, and wasted tax money. Plate tectonic theory dominates the earth sciences as evolution dominates the life sciences. And despite the growing recognition of their scientific problems, because schools and the media ignore competing explanations. For example, earth science students are frequently discouraged from considering alternative explanations. Too often, students are told what to think, not taught how to think critically. And I see that a lot at St. Cloud State. Kids know what to think, but how to think is very shaky. Okay? So this is why it's happening. Before the field of geology began in the early 1800s, a common explanation for major geological features was a global flood. But many geologists were opposed to the Bible, which spoke of a global flood. So instead of appearing closed-minded by disallowing flood explanations, a more subtle approach was simply to disallow global catastrophes. Professors, primarily selected from those who supported the anti-catastrophe doctrine, did not advance students who espoused catastrophes. Professors also influenced, through the peer review process, what papers would be published. Textbooks soon reflected their orthodoxy. This practice continues to this day. And that's true, because major criteria for selecting professors is the number of their publications. So their mantra is publish or perish. And if you question plate tectonics, you ain't going to get published in America anyway, probably. Okay, this anti-catastrophe doctrine is called uniformitarianism, where only processes observable today and acting at present rates can be used to explain past events. Okay, but Mount St. Helens proved that that's a poor and an arbitrary assumption. So there's a dilemma. Because uniformitarianism is foundational to geology, should the entire field be re-examined? to allow scholarly consideration of evidence that implies a global flood, most geologists object, and the geology professor I debated objected to that. He said, he agreed that there was a global flood. He agreed there was a whole bunch of global floods. And I said, you mean where the whole Earth was covered with water? No, just floods that went around the globe. And so he'll agree that there's global floods, but none of the floods could cover the whole Earth. So they're getting closer. It's a far cry from their uniformitarianism, which they had in the past. Okay, they deny that a problem exists or hope it goes away, or they redefine uniformitarianism, which is happening and has happened. They're allowing for catastrophes now. They just don't allow for a worldwide catastrophe, but they're getting close, as far as the global flood. He did say that he went along with, the meteor striking the Yucatan Peninsula. That was a worldwide catastrophe. But there's a lot of problems with that one, too. Tim Clary shows how it couldn't have been a comet there. But anyhow, the problem will not go away. Ruling out catastrophes in general and the flood specifically, even before all factors are in, has stifled study and understanding. Widespread belief systems seldom change when frequently reinforced by influential institutions. And they seldom change when you're not allowed to see another perspective. They seldom change when you're not allowed to think about something else. But when a vast number of people realize they've been misled, intellectual revolution begins. Like when Copernicus and Galileo showed that the Earth and other planets orbited the sun. But back then, as in today, fixed opinions will resist this shift in thinking. Because Thomas Kuhn wrote the preeminent book on how science works. In it, he shows that such monopolies continue in science, often for centuries, until startling new evidence arises along with a theory that better explains all the evidence. Then a slow re-education process begins, accompanied by hostility from those whose income, power, prestige, and pride are rooted in the old theory, such as uniformitarianism and evolutionism. Correcting these errors, now ingrained in the world's social fabric, will require a willingness by many to study, educate others, and follow the evidence wherever it leads. Okay, and so I'm so thankful that you're here tonight and that you can educate others. This is very important. When people reject the God of the Creator, it is frightening, the world that they imagine. And we've got some quotes by Yuval Harari. I'll show them out in the hallway if anybody wants to see some quotes that aren't going to be, aren't on the news. There's information that's clear out there, but we'll do that out there if anybody wants to see that later. Okay, all theories should be subject to analysis, critique, and refinement. With theories and their predictions clearly enumerated, field work becomes more exciting and productive. Most important, those who follow us will have something to build upon. They will not be told what to think. Okay, and teachers and parents and pastors, by the way, have a simple, satisfying task: provide information. That's the main thing. Let people think. Ask questions, challenge answers, and allow students and congregations the excitement of discovery. If we just only allow them to see one side, people don't think, and I think that's very dangerous in society. And then throughout the history of science, experience has shown that the simplest theory explaining the most details is probably correct. Well, there's nothing simpler than one assumption. Walt Brown has worked on this thing for 40, 50 years refining this theory, and it's now in the 9th edition, where he has one assumption, and it logically explains 25 major features, from the mid-oceanic ridge to comets and asteroids. And this theory makes accurate predictions. It's validated by NASA discoveries. It's so exciting. So I encourage you to see both sides. Again, check out this side to see if Walt's right. Check out the debate and listen to the geology professor to see how his arguments. He had some good, strong arguments from his perspective, his interpretation, and so you just have to decide which interpretation you want to believe. And I'm all open for people seeing both sides. I'm not saying just look at this one, I'm saying look at all of them. And use the same criticism and thoroughness on this book as you would in the science textbooks that you're paying for. And that's what I hope that happens. But I encourage people to see both sides, think critically, explore with open minds, and then let the adventure begin. And the best way to do that is start at creationscience.com. Okay, so then we had the opening statement, the rebuttal, we had the cross-exam, and then there was Q&A for the audience participation. And I'm just going to go to my closing comment. Hopefully we can get freedom to think back in academia And once that happens, we're going to have a scientific revolution. And so I do thank Dr. Feldman for participating. And my big thing about doing all of this is, creation points to a creator, and the creator revealed himself in a book. And it says what Jesus did for us to pay for our sins. And we pray that people would put their faith in Christ so they can escape the penalty of hell. And we just pray that for anybody watching. This is what happened to Ron Neller. I encourage you to listen to his testimony. He studied this for 30 years, and the evidence pointed him to a global flood. And then he said, well, the Bible says there was a flood. Maybe there's a God. And then he went into it, and he actually found that there was a God. And to think we all got here by chance random processes takes way more faith to think than we got here by a creator. And that's why we do this. There's a lot of lies in our textbooks. There's a lot of lies in the media. There's a lot of lies in academia. And if people believe those lies and don't put their faith in Jesus Christ, that's very serious. And so that's why I do what I do, and that's why maybe you guys are here. But there's a battle of ideas out there, and there are eternal consequences. And so with that, you just learned all my mistakes. There's a lot of things I wish I could have done differently, but I swung the bat, and I'm glad I swung the bat.
Do them again?
I don't know. In the comments, he says he's never doing this again. He's a sedimentologist. So I don't know if we will or not. Hopefully, maybe I did bad enough to have one of the experts do it next time, So we'll see. But yeah, so that's how not to debate a geologist. Does anybody have any questions?